some
to begin with, Dr. Parmar, I don't think need some introduction, but let me read out some small introduction about him. Mr. Dr. Parmar is director in Nitra Lab from last almost 26-27 year. With this, he has given almost 120 articles in various national and international journals, and he has conducted PhD, MSc and BTech for more than 45 projects along with the students, various industry, and he is chairman of BI section of committee in technical textile for mobile tech application and various BI section committees. As far as the topic of today is concerned, which is recycling and application of textile waste in different products. Disposing of textile waste is a very big problem. Textile waste covers a wide variety of products, including fiber, yarn, and fabrics. It is estimated that around 92 million tons of clothing waste are thrown out every year globally. Most of the portion goes into landfill. This is not only a cause for environmental concern, but also represent a waste of useful resources. Reconverting waste clothing material by mixing it with resin can be explored for developing high quality products like wall and floor tiles. Keeping this in mind, in this study, various types of textile waste like denim waste, fiber from spinning like hemp, polyester, flax are used to develop wall and floor tiling materials having water and flame retardant properties. So similarly, agriculture waste was also utilized in making various products including tiles, bricks, manhole covers, and drainage cover slab. The development tiles were also tested and compared with the conventional ceramic tiles. So this is quite interesting subject which Dr. Parmar has taken up, and I'm sure with this today webinar we'll get a lot of insight and how the future can be seen with the disposing of or utilizing of this textile waste into the various byproducts or the different products. I hand over to Dr. Parmar. Dr. Parmar, you can take the charge now, please.
Good morning, everybody. I'm audible?
Yes.
Yes. Sir, I'm just starting my presentation because it may take much time, so I'm not wasting much time over here. Let me first share my screen. I hope you are able to see this slide. So I'm going to present this presentation on recycling and application of textile and agriculture waste in different products. I am going to cover some agriculture waste also because that is also burning issue. So let me start in this way, that team first, because that is a most important aspect in any study. Some of the team member I have given over here, Dr. Nidhi Susudia and Dr. Archana, they have worked with me during PhD's work. I am going to cover different, you can say, topics over here. There are small topics that I will take one by one, but most of them are related to this. That first I will cover that waste generated by textile industry and its impact on environment. Few slides I will show over there. Some waste recycling processes that is being used in all over the world that I would also like to discuss, because that recycling process can also be used over here in India. Some study carried out by Nitra on recycling textiles and agriculture waste, and various product that we have developed with textile waste, medical textile waste, and agriculture that I am going to discuss over here. So if you see environmental point of view in textile and clothing industry, Everybody know that it is a second largest pollution creating industry over here. Even if 1 kg of cotton, if you go start from cultivation to its end use, it consumes 10,000 to 20,000 liter of water. I have given the references also over there. 70 to 20% of water is polluted by this textile and clothing industry only. And this industry generate around 21 billion tons of garbage per year. And 10% global carbon emission is there if we are working or we are in a textile and clothing industry. So we are creating such type of environmental related issues. So which we have to work. What is textile waste? Everybody know. I am just given one slides because a few students also will be there. They must understand this thing. Textile waste originates from the community via a number of streams, including the fiber. When we are working in spinning mills, then we get that type of waste fibers also. When we are working, we are making clothing or weaving clothes, we will get some waste over there also. Waste coming from consumer, then when they are using cloth and throwing it away. Commercial and service industries also producing various types of waste, like hotels industries, they are having waste cloths over there, they are also goes in a waste. Okay. So mostly it is classified as a pre-consumer textile waste and post-consumer textile waste. Pre-consumer means that it is in just in a manufacturing stage, it may be from spinning, it may be from weaving, it may be from garment industries. So that comes under the pre-consumer waste. And post-consumer textile waste, it may be afterward. That is when we are using cloth and we are throwing it away. That comes under the post-consumer textile waste. If you see globally, an estimate of 92 million tons of textile waste is created each year. And we feel that, and as per the study, by 2030, we are expected to be discarding more than 134 million tons of textile a year. So that waste is where it is going. It is going most proportion goes into landfill. That is also creating very big environmental problem. And you know, if we are working in a spinning mill, especially in cotton spinning mill, you are providing that you are creating waste in different area. Blow room you are getting, carding, combing, and everywhere you are generating small waste, and ultimately you are getting a big lot of that waste fiber. If we take one industry, that is a denim industry, you can see that most of these industries, it generate around 15% of waste of cloths. That is cutting or these types of small pieces you will get from denim. Even the yarn is there. When you are making denim in dyeing process, there are various types of technology available. It may be sheet form dyeing, it may be row form dyeing, and in each and every process of dyeing, yarn dyeing, finally you are also creating a dyed yarn. Some of the yarn you have to, it will go automatically to create waste also that you cannot utilize. So I have taken one example of denim over here. There are number of industries, that number of manufacturing units that created different types of waste also. If we see the garments, generally 3 year, the average lifespan of a garment. 3 year. After 3 year, what we are doing? We are throwing it away. Okay, it goes in waste. So textile generate a huge amount of waste in this way. And 5% of all global landfill are being taken up by dumping textile waste. So that is also here one of the greatest problem over here, that we are dumping these textiles in a landfill, and it create a problem in soil, and environmental problem also there. Sometimes what we do, we burn it, these leftover clothing or cutting or garments, we burn it. It creates environmental nuisance because it releases highly toxic fumes into the surrounding area. The analysis of the presence of textile waste in municipal solid waste, you will see that many times you will get that these discarded clothing items over there. So it is also creating problem for these municipal committees also, because they choke these all types of that are nalas and etc. Though that can also create problem for these municipal workers. So this is not only a cause of environmental concern, but also represent a waste of useful resources. Means that clothes which we can use for recycling purpose, we are wasting in this way by burning and throwing it away. If we use it, if we reuse it, then we can save our these resources also, and also reduce environmental problem. Where we are recycling, if you see, we are also working on recycling. All industries are trying to recycle these textile material in various way. Sometimes we use that used cloth or in the wiping as a wiping cloth. 7% industries using that type of material. If we see the filling material, means a threaded or stuffed material, mattresses or insulation, we generally use 9% of that recycled textiles over there. Fiber reclamation, or that we are recycling fiber, means converting all textile clothing items or material into fiber, and then making again some product out of that. It is 8% we are using over there. And second hand clothing, that is the cloth which are sold to other country, poor country, they are using it. 70% share is that there, and some material which are not, and these types. The 6 quantity of that also. So this is the overall picture over here. So studies or some work to apply this, they are using a fuel for making that bioethanol. There is a one company that is environment planning, recycling company, is finding a method that will allow cotton fiber to be extracted from used clothing, and that textile during a fermentation process, they convert it into fuel. According to that company, they can generate around 700 tons of bioethanol from 1 ton of that used cloth. Now they are working with the Japan airline, and by 2030, they confident that they will able to generate fuel for their Japan airline, and in this way they are moving ahead. So that is the area they using fuel as a fuel for this waste cloth. Another that is creating a solid fuel from waste textiles. Clothing deemed unwearable is transferred into energy in the form of calorie dense solid fuel. That is also very, very useful, because that fuel substitutes fossil fuels and are used for industrial purpose. You can use in your boiler and other area also. So that is also going on in the world. There are various types of various types of reuse, recycling of clothing of these used cloths are showing over here in this one, in this slide. You can see that making their board are there, making cover of this mobile, and so many area. Even you can see that textiles carpet also. That is very, very popular over here. Nowadays, most of the our automotive industries, they are using recycled, the carpet made out of no limitation, this cotton every. So that is going on in the world. Industries also, they are making that. And another very important use in India, I must say over there is a Chindiwala, we call it. They collect cloth from households, and they finally they sold it to industry. And the industry, especially in the Panipat, you can see that they are reprocessing and converting waste into fibrous material for making sodi yarn. It is a very, very common recycling process over there. And they are using that sodi yarn for making carpets and rugs. And same sodi yarn, if they form, they create or they generate or they prepare from woolen cloth, they use it again into making blanket. That is very, very common that low cost blanket can be made out of that. They can use it cushion, cleanup product, home insulations also. They can use that sodi yarn or these types of fiber. Stuffing purposes of mattresses, geotextile, landscaping, and concrete reinforcement also. Uh, they are using that type of fiber that they develop from or they recycle from used clothing. Nowadays, a new process has started in world over. That is the aramid. How to recollect, how to recycle that aramid fibers or some costlier fiber. You know that the used aramid fibers or other such inherent FR fiber based products used in various life-saving protective textiles are also being tried for recycling to develop new product, because these inherent heat resistant and flame retardant textiles are very, very costly. So it was tried, now it is successfully, they have uh, uh, recycled that fiber, and these para and meta aramid fiber they have recycled. Even the polyamide, especially nylon 66, they are able to recycle it again, and they are using it into again in bulletproof jackets. Even that bulletproof jacket that is very old, they take it and they take it, and that the fiber they have extracted from that bulletproof jacket, and that fiber can be used for making new bulletproof jackets and new product out of that. So that process is also started worldwide. Recent study, if you see that this 2018 Journal of Cleaner Production, what they did that these scientists had reviewed 41 studied that study especially on recycling, reuse, and etc. So they have done a just collected data out of that, and they found that fiber recycling is the most studied recycling type, 57%. They see that the recycling, the people are talking about that in these papers, that is 41 papers, 57% are discussing about recycling process, and other 37 are related to the recycling of polymer, oligomer, that is a polymer material, monomer also 29%, fabric recycling 14%, and cotton 76 and polyester 63 are the most studied material over in these articles. And what they claim that textile reuse and recycling in general reduce environment impact compared to incineration and landfill, and that reuse is most beneficial than recycling. Means that reuse, recycling, that is a good thing compared to the incineration and landfill. We should not go for these types of things, that we should not burn these clothes, and we should not use these clothes for landfill. We should recycle it, reuse it. So that is the study they have carried out. And one of the recent study carried out, that is the enzymatic textile recycling. What they did, they did a simple thing. If I want to explain in this way, that they are mostly concentrated on polyester and cotton blended textile material. What they did, they use a special type of enzyme, and they dissolve, or they through enzymatic hydrolysis, they dissolve that cotton portion only. So now you will have only polyester portion, and that polyester portion can easily recycle. So they did that type of study, and they have made some process over there, how to treat that polyester cotton blended fabric with enzyme. So that study is also going on in the world. Now comes to the main study that what NITRA has done on recycling of textile and agriculture waste. So we try to develop various products out of that textile waste as well as agriculture waste, and we develop floor, wall, and roof tiles. Even we have developed small bricks out of that. Manhole covers, drainage slabs, that is also developed. We have also carried out some study on mulching, that I will discuss later on, and garment and upholsteries that also develop out of that agriculture waste material. So that I am going to discuss over here. Now I am just starting about that various types of product developed from textile waste. And first I am going to discuss about tiles that is developed from textile waste. And also we have developed from agriculture waste these types of tiles. And tiles are widely used for flooring in the kitchen, bathroom, parking lots, and rooftops, and are also used as a tabletops of dining room. Everybody knows that. That is not a new things. Just I am introducing about the tiles only. What we did, we have collected waste material from denim industries, as well as spinning industries of various types of fiber, like cotton, polyester, flax, hemp, various types of fiber we have collected from industries, as well as in our pilot plant also. We cut that denim fabric in a small pieces, which you are able to see in the slide, and we use that one for making a tiles. And what is the advantage? Our tiles on ceramic tiles, both one, it reduced the dependency on ceramic tiles, as these tiles will is using for making these tiles, we are using textile waste, so that dispose of textile waste problem can be reduced. And as we are using various types of material over here, so the durability of these tiles are ceramic tiles. So what we did, we have taken one reinforcement material. Here the reinforcement material was denim waste, flax, cotton fiber, and hemp fiber. And a matrix is used, in which we have used various types of resins and hardener for making that type of tiles. This is the process sequence, just to make this process easy. We have made this slide, and you can see over here in the first part, what we have collected textile waste, and we have cut it into small pieces. Especially in the case of fabric, we have to cut it into small pieces, and then we have to mix it with that resin and some hardener, and then we have to make point. We are making it a tiles, and during that process, we created such type of solution with resin, with some flame retardant chemicals and water repellency. So these tiles become a flame retardant as well as a water repellent also. And then finally, in the fourth part, the analysis of physical and mechanical properties were carried out on these developed tiles. You can see that different types of tiles I'm going to show over here. You can see where various product you can use. You can use even that simple jute bora. You can take saris also. Small. You can see you can take the sari cutting, and you can make tiles out of that also. So these are the tiles we have made out of various product. we have done a study of physical and chemical property of these tiles. These are the standard test method we have taken. Tensile strength we have carried out by ASTM B638. Flexible rigidity carried out. Absorbency of tiles, that is also very important. It should not absorb water. Shock and heat stability test were carried out. Its nature with chemicals also analyzed. Determination of linear thermal expansion, water repellency, and horizontal flame retardancy. These last 7 and 8 tests is related to see whether our tiles are water repellent, and secondly, and eighth was related to flame retardant property of these tiles. And we have developed many types of tiles using many products. So one of the product which we have developed out of denim shows a tensile 18.699 megapascal, and its fluctual rigidity is around 9.8. In the case of polyester fiber, we have used polyester fiber also. I think some disturbance is going on. Somebody
Dr. Saab, 1 minute. Ankit ji, please mute your microphone. Yeah, thank you. Yeah, please, Dr. Saab.
So we have used the polyester fiber also. In the polyester fiber, and that strength is 9.9 megapascal and rigidity 2.61. And similarly, in the hemp, you can say 7.5 here and 2.31 is a fluctual rigidity, but it can be changed. It depends on quantity of fiber, type of material which we are using. So it is you can change it. If you increase the quantity of polyester fiber, you will get different types of strength and fluctual rigidity. It depends on type of tile you want to have. So we have compared it with the tensile strength of material which is not having any types of textile waste. That is only resin and hardener is there. So if you see in the diagram, in the last one in the note, we have given that the 6.5 megapascal is the strength of tile, which is made out of a simple material using resin and that hardener, and flexible rigidity 2.2 megapascal. We have carried out absorbency test also. It was around 2%, that is under limit. And in which what we do, we take that dry tile, weigh it, and dip into water and boil for 2 hours, and then remove it tile again, and then again weigh, and the difference and percentage we calculated accordingly. And this is the absorbency. 2% absorbance. We have carried out a flame retardancy and water repellency product test also. And if you see the fire retardancy, you will get that all the tiles which we have developed are self-extinguishing. Means when you remove the that source of ignition, they will not burn further. So that's why it is called self-extinguishing. And the water repellency, you will see that all the tiles are water repellent because we have treated it with water repellent material. So all the tiles are water repellent. Now comes to the another very important aspects, that is converting these all types of medical waste one can say, but on all are related to textile only. Of course, when they are
excuse me, Dr. Parmar. Excuse me.
Yeah.
Excuse me, Dr. Parmar.
Yes,
I'm just requesting. I'm just requesting the authority.
Shall I continue?
Yes, sir. Please.
So in this slide, what we are going to show you that converting all these types of material, that is coverall, shoe cover, and face mask, how to use that one waste material. Of course, we have carried out that study in our laboratory only. So you have to take utmost care when we are going to make this in bulk. So huge quantity of medical waste comprising coverall, shoe cover, and mask generated during the second peak, mostly second peak of the pandemic between April 2021 and June 2021. The disposal of the waste is a difficult task. Mostly this waste was disposed of using incineration, which also create an environmental problem. So some study I would like to discuss about some study which in world over which is being carried out. These studies are carried out in uh, different universities. A researcher at RMIT University in Melbourne, Australia, they have carried out and they have used these types of disposable face masks and these types of coverall in making roads. They have cut it into pieces, mixed it into that material, raw material, and then they have made the road also. According to them, they are, if we use 6.8 billion face masks a day, researchers want to turn them into goods. That is the topic they have mentioned, and that they have used it into this way also. That is also a very good study they have carried out in Australia. And in India also, one of the article and blog is there, that is gut pathogen. Look into how easily and economically scaled up recycled PPE can be, as well as how this is instrumental in easing global PPE shortage in any biosafety facility or in healthcare setting during pandemic situation such as COVID-19. That article is also there. What they did, they have used vaporized hydrogen peroxide, and that hydrogen peroxide work on the breakdown of hydrogen peroxide to generate oxidative stress, which in turn incapacitates and destroy the microbe. Means simple way that they are using hydrogen peroxide, vaporized hydroperoxide, and that vaporized hydroperoxide kill that microbes. Okay, so what they did, they have taken the used PP and coverall or these types of face masks, and they have treated it with vaporized hydrogen peroxide. And according to them, one can use it again because there is this vaporized hydrogen peroxide will kill all these types of microbes, and it can be treated as a fresh coverall and all types of mask and other things. So that study is also carried out, and people are working on that area also. In one of the interesting study that is carried out on these reuse of these types of material, what they did, they have made tools out of that. And this is I have given that link also. If you click that link, you will see that what they did, they have made the tools out of that. Various types of tools they have made. They have cut this material and mold it, just like a mold it and mold it into various types of tools. That study is also carried out. In our case, what we did, we have taken various types of product, coverall, mask, and shoe cover. We have cut into small pieces, which is we have shown over here. We call it reinforcement material, and we have treated it with other chemicals also to clean it properly to kill all types of microbes. And then what we did, we have developed various types of tiles. You can see the different types of tiles out of these types of product. Some of, as per the design, you can make various tiles. These tiles we have made out of these coverall, face masks, and shoe cover also. So we have made 5 types of tiles out of that, and we have tested it for tensile strength and flexible rigidity, and these are the property. And I have already mentioned that that property may vary depending upon the type of material you are using in making these types of tiles. Another very important area nowadays, that is developing various products from agriculture waste. You can see that the gross world over, I am telling gross residue, total amount of residue produced is 686 million tons from 26 crops. That study is carried out on 26 crops, and they found that the residue is 686 million. And out of that 686 million tons, some of that material is being used for different areas, and out of that 234 million tons remain as such without any use. Means 234 million tons per year waste is not being utilized anywhere. Somebody burn it and or somebody throw it. That is going on. So out of total residue produced in India, if we see in case of India, rice, wheat, maize, barley, these are the most common crops over here, and they are generating most of the waste out of these crops. For quick disposal, what they do, they burn it. And what is the impact of that burning crop? You all know the environmental impact is there: air pollution, particularly greenhouse gases, nutrient loss of soil. That is always, everybody know that thing. 1 ton of crop residue on burning releases 1,515 kilogram of CO2, 90 kilogram of carbon monoxide, 3.83 kilogram of a nitrogen oxide based or nitrogen oxide based gases, 0.4 kilogram sulfur dioxide, 2.7 kilogram methane, and 15.7 kilogram non-methane volatile organic compound. That is the impact on environment we are creating by burning these types of waste. And if you see the human impact on human, carcinogenic and lung infection, that is a most important, and eyes irritation, asthma, suffocation, dizziness, headache, fatigue, chest pain, difficulty in breathing. These all are the after effect when we breathe in that type of environment where these types of gases that comes from after burning these crops. And indirect effect is also, if we are moving in a car or in any bus or any in a road, due to smoke, the visibility may be poor, there may be chances of accident. That is an indirect effect. So keeping this in mind, we start working on utilizing agriculture waste in building material. And especially we are talking about tiles and other things. We mix it. We first, what we did, we have collected that type of crops, and we extracted fiber out of that. And that fiber material we have mixed with the matrix, and we have created tiles out of that. We have made bricks also out of this. And these are the tiles. You can see the all material that is related to agriculture waste only. You can see various types of tiles we have generated. Even if one can make a brick also, small bricks I have shown over there. So if you can have, you can design it in different way also. So so these are the tiles we have generated out of that. So I am showing you one slide that already shown how to make tiles. So another very important, this is only one slide I am going over here, making a mulch out of agriculture waste. You know that whenever sometime we have to go out for some tour, some other places, and you are having plants in your home, even a small gamla is there, you are having a small plant over there, and that is a very difficult situation, how to water it, how to provide moisture to that plant. So during gardening also, the mulching is always used. They are using, if you see in the gardening, if their gardener is there, they are using wood chips, leaves, even stones, and making a landscape also on the surface. Main aim of that is that to retain soil of the moisture. That is the important point. So we have developed a new types of mulching that it has a property to retain water 7 times of its weight. Its weight is very light. I have shown you that mulching over there, mulch process. It is very, very light. It can absorb 7 times of its weight of water, and that we can put in that plant that I have shown over here. First, we have what we have to do. We have to put it into water. It will absorb water and then remove it and put into plant, and it will you can go outside for 4, 5, 7 days. So it will create moisture in the plant, and when you come back, you will see there is no problem. So that also, that type of product also can be developed out of these types of textile waste. Another important aspect is the developing these covers of drainage and manhole. These types of things can also be made out of these waste of clothing items or textile waste. You know that in case of especially these cast iron manhole covers, and it has a poor durability, corrosion is there, and due to that there may be chances of leakage of hydrogen sulfide gas that is not good for health, and it is very heavy also. We see that what we did, we have collected various agriculture products from these corn husks, sugar cane, paddy, and other wheat crops. And you know that a large number of agriculture waste biomass is generated from these crops, which is found in abundance in this region, especially in India. As the production of corn, paddy, wheat, and sugar cane is increasing, so the agriculture waste also increasing. It is an underutilized waste, and the common practice in India to get rid of this waste is to burn it. In this work, prototype of green manhole cover, drainage cover were developed, and it will improve the existing technology of manhole covers and drainage cover, and also help farmers to get some extra income. So we have developed these designing cover. You can see over here, we have developed these designing cover over here out of these waste. Now, important thing, and the last, you can say last slides I am showing you, few slides are left. That is related to making garment and upholsteries from corn husk. That is a very important thing if you see that. We have done that work, and that is a very, very successful work we have carried out, how to use that corn husk for making garments. So we have collected that crop, these waste from Ajadpur Mandi. You can see that type of things. They are real picture we have taken from Ajadpur Mandi. And Aterna village in Panipat, that is, they are having, they are working on these types of, they are producing these maize over there. So we have collected waste on, from Panipat also. And that waste, what we did, we have taken that fresh corn husk, we dried it, and we cut it into small pieces. And that pieces we have shown over here in the four slides. And that slide, out of that, we have done, we have extracted fiber out of that. This fiber, that fiber is shown over here. We can bleach it, we can dye it. Various types of fiber can be generated out of corn husk, and you can spin it. What we did, because the fiber was coarse that time, we have used that ambar charkha for making yarn, and you can make a different blend. Corn husk with cotton 30-70%, corn husk polyester 30-70%. That is a hand spun yarn we have made. Even you can use the acrylic also with corn husk, and polyester also with corn husk. Corn husk is having a very good absorbency. It has moisture content around 11%. So it is a comfortable type of product over there. What we did, we have made various types of garment over there. That garment we have shown over here, very different type of design of garment are shown over here. You can see that type of garments also. These are the other, some picture of garments. And we have developed some upholstery product also on small scale. These are some curtains and those. So these types of studies we have carried out on clothing item, textile material, and agriculture waste, and we have covered all types of things related to cover all as well as a face mask and shoe cover. Shoe covers. So one can use these type of material for making tiles or any other material. Even one can make a table also out of that. So this is our study which I have presented over there. If you are having any question, you can ask. Thank you very much.
Thank you, Dr. Parmar. This has been very, very illustrative and very educative. Uh, we had actually thought that you would be talking only about wall and floor textiles,
Yes.
floor tiles, but you
Yes.
have covered a lot of other areas which generates a lot of interest.
Yes.
And from the chat box, we can see that this, as we had anticipated, it would generate a certain amount of interest. It has generated a lot of interest. And you have a plethora of questions which you can answer, some of them right now, or some of them can be taken up later. But the fact remains that what you have touched upon is just the tip of the iceberg. It is the overall waste in general is very, very vast. Textile waste contributes a very major factor to that, with all those wastes that are being generated. And the time is definitely right for us. In fact, we are already past that time when we should take a lot of focus. We should have a lot of studies on recycling and sustaining our resources. I think this is the message which has been sent across by you and by all the scientists who are working on recycling of fibers and products. And this is a very, very important issue because we have to generate only, we have to use only what we generate so that it becomes a completely sustainable cycle. Otherwise, we will be depleting our sources. And the generations tomorrow are going to accuse us of excesses for which they will be suffering. Thank you very much. And I think the floor is now open for the questions. Please.
Dr. Parmar, can I ask a question?
Yes, sir.
Dr. Parmar, I am from Park Non-Woven Private Limited, Pankaj Kapoor from Panipat.
Yes, sir.
My question is that we are also using a lot of recycled fiber for making non-woven felt. The issue here is that for you to promote is the recycling is that should be some kind of cheap electricity provided to the people who are using recycled material. Number two, there should be a land provided at a cheaper rate because this industry requires a lot of space for sorting, storing, and it's a very fire hazard also. So this is because there's a lot of fire happening in Panipat industry, as you must be knowing about it. Second point is that whatever study you have done, is it patented, or anybody can come to you and have the details from you? And is it commercially viable vis-a-vis the tiles of the normal structure carpets?
Sir, I am going to reply your last question that is related to tiles only. In that case, yes, we have applied for patent, but we are open for commercialization also. We can ready to work any industry who want to work with us. There is no problem for that area. So it can be commercially viable also. There is no problem about that because we have compared its property with the ceramic tiles which is being used nowadays, that is conventional tiles, and we found that it is good in compared to that one. So there is no problem, sir.
So we can send our people to your office in Ghaziabad and get the details.
Yes, sir. We can have a discussion, sir. No problem, sir. We can discuss.
Very fine. Very fine.
Thank you, sir.
Very fine.
Thank you, sir.
Hello, sir.
Kapoor, sir.
Dr. Parmar, this is Mamta from Chennai. And
Yes,
I am an ex-software professional, ended up being looking at the textile waste in Chennai. It ranks high in India per capita waste. So textile waste is a huge thing that as evident by your presentation also. So I have saved this tailor's cutting waste 300 kgs. I'm working solo in Soho from my third bedroom. and I am really having a lot of issues and what I need to do, that fillers and all, how do I convert? So I need a lot of knowledge, support and all. How can Nitra or others in the room now in the session can help me out?
Ma'am, you can do one thing. You can write down us. Even you can write
Okay.
down Textile Association also directly. There's no problem, and
Okay.
we can discuss that matter. There's no problem. We can jointly do some work.
Okay. Is it like because I'm in Chennai, I cannot reach out to Nitra? Is it like that,
There-
or I can reach out?
Nowadays there is no such type of thing. Even we can
Okay.
discuss on Zoom also. We can discuss on various
Great.
networking also.
Great.
We can have discussion. No problem. We can solve this problem.
I'll reach out, sir. You have
Okay.
shared your email ID and LinkedIn. I will be
Yes.
asked. Thank
Yes.
you. Thank you, sir.
Mamta ma'am,
Sir,
knowledge has no boundaries.
Yes. Yes.
Knowledge has no boundaries. So you will not be bound by geographical boundaries as such. You are free to get in touch with anybody in the room.
Okay,
And
sir.
I'm sure that I'm speaking for all of them. And I'm sure that you'll be able to generate a lot more ideas, a lot more work in this particular field. Thank you so much.
Thank you, sir. Sir, I did not get your name, sir. It's written as Galaxy A31.
My name is Kamal Mishra.
Okay, sir. Thank you. Good. Thank you. Glad to meet you.
You're welcome.
Dr. Parmar, this is Vivek Karmukar.
Yes, sir.
It was really, really great to hear and go through your presentation. Dr. Parmar, I'm a sculptor and I'm also an academician associated with a few universities. It will be great if we can, kind of open this information, also site visit for students, because if you catch them young, then they're more aware of such innovations.
Yes.
And since I'm associated with design institutes generally nowadays have maker labs and innovation centers. Do you also collaborate with universities in that respect? Because like I was seeing your products, I think it'll really benefit from the design aspects of it, making aspect of it, and also informing the students about these new ways of recycling. More so because till 2030, the UNSDG goals are open for all the students and for the citizens to contribute in. And more students get into this. It really help, the generation, the upcoming generation, as Mr. Mishra also pointed out.
Yes. You can send us a mail, sir, that
Yes.
we can arrange that way that your student can visit over here. We are having a engineering institute also. Okay. So
Okay.
research association is one part, and there is a college also. We are having full-fledged engineering college also of textiles and computer science. So you can send your student there, no problem. You can send first mail. Accordingly, we can arrange visit of students also, and we can have some MOU also. If we could able to work on some project, that can be done. No problem.
Lovely. Thank you so much.
Dr. Parmar, Dr. Vivek has been in several chairs, and he's a very talented gentleman.
Yes.
With a lot of work in several areas. And I'm sure that in this particular project regarding your wall and floor tiles, he can be of immense help in adding aesthetics to the entire process. Thank you so much, Vivek. Thank you for joining us.
Thank you so much. Thank you very much. My pleasure.
Any further questions, please?
hi, sir. This is Pranav. So my questions to Parmar sir. Sir, first of all, thanks for this great presentation. So I have a query. We have already commercially implemented this project, or it's only at a lab stage?
Sir, we have not having any tie-up with some any industry. We have developed it on a lab scale only. We have made various tiles and various product out of that. Now we are working. We are looking for some industry that so we can join hand with them and we can start. because you know that it is not a already established industry. There is no such type of thing. Let me take one example. If we are making some special type of fabric, like a firefighter suits or something else, so there are already established industries are there. We can easily tie up with them. They are having manufacturing facilities. Everything is already set. So there will be no problem to do these types of bulk thing. But in that case, this is a new area. So there is no established industry over there. So if somebody want to involve it, so they have to work from the start. So that is the thing. If somebody want to involve us, so they should ready for that, because we have to start from the starting point. Okay.
Great, sir. Thank you, sir.
Dr. Parmar,
Yes,
this
sir.
is Shailesh. Congratulations, first of all,
Thank
for
you, sir.
this very interesting, very innovative topic, very exhaustive talk. And I must congratulate you and Nitra for this great effort, and to Tai also for providing a good platform. My 2 cents here. One is about the commercialization. Some friends have raised question about commercialization. But the big issue is that with the kind of PPE and masks that we are disposing, unless we find an alternate use as Nitra has done, this will be a big health hazard. So with commercialization or without commercialization, this is the area we have to look into, be it in tiles, be it in bricks, be it in roads or pavements. That's one thing. The other is in form of a question that have you done any tensile studies where you have used PP and masks in bricks or tiles, etc.? To what extent it improves the tensiles or other similar behavior of these geotech or built tech materials?
Sir, I have already shown that in my slides that we have carried out tensile strength, flexural rigidity, many other tests also on that one, and also compare with the existing tiles. So it is found to be better compared to that one also. That we are all the study we have already carried out. Regarding your first point, that is 100% right, and I have also mentioned over there, when we are going to use these mask and coverall and these types of things, we have to take utmost care, and we have to select the product, that type of product which is not having any type of that doesn't create such type of problem, that health hazard and other things. So we have to take utmost care on that.
The last question to this in the same context, say if I use a mask or PPE which is having some coronavirus in it, then I use it in geotech or built tech material, some brick or tile, etc. Of course, it will be treated to some higher temperature.
Yes.
So after that, has there been any studies that is the virus still there?
Sir, studies that I have shown, one study for even Indian study, they have used hydrogen peroxide, vaporized hydrogen peroxide. They have treated that mask and they have carried out again study, and there were no any such type of virus there. So the study are there. So they have used that way. They have that microbes are killed during processing with this hydrogen peroxide, vaporized hydrogen peroxide. So such type of things are there, and one has to do that if they are going to use these types of product in developing tiles or roads, etc.
Microbe and bacteria are easy to kill, but something like COVID is a deadly thing. So any specific study on that?
Excuse me, Dr. Parmar, may I intervene for a moment?
Yes, yes.
Yeah, Shailesh, when we talk about corona, the COVID virus only has a shelf life of say 6 to 7 days. It does not survive unless it has a host. So that is one thing which has to be, when you talk about waste being used for this particular exercise, you have to understand that they have been in storage for a fairly long period of time. So even if there was any virus, it will die on its own, number one. Number two, as it is, Dr. Parmar has already said that they would be treating them for the bacteria and other infections. So I don't think that is an area for worry. Thank you so much.
My concern was, sir, that bacteria and virus are quite different. So there are a lot of things which can kill bacteria, but to eliminate something like COVID virus is entirely different thing. That's all. Thank you.
Yes.
COVID virus only needs a host for it to survive. Otherwise, it is not. Sorry. Please, the next question, please. Mr. Manchanda, I believe, is coming up with a question. Mr. Manchanda.
So I had another question, Mamta here. Can I?
Yeah, please.
Dr. Parmar, this waste is really huge, right? So it is either getting landfilled or incinerated now. And mostly it is getting landfilled also. So has NITRA or any body in India has conducted a research, thorough research on what is the impact on the pollution on land, air and water?
Ma'am, if you go through research or studies, you will get a study on that. There's no problem. A lot of work is carried out, and in that research, they have shown that if we are using these types of clothing items, especially when it is a synthetic in nature, not biodegradable, or cotton is there, no problem, but polyester and other material are there. So they are impacting on badly on this soil. So that study you will get.
And recently there were fires in Chennai landfills. So and the report has not yet come out, like what was the cause and all. Obviously it is methane, and methane definitely. So I was looking for these kind of reports also. I will reach out to you, sir, on email if you can help me out. Yeah, thank you.
Thank you.
Ms. Mamta, there are lots of studies on the leaching of chemicals when we put textiles in landfills. A lot of chemicals are used in the textile process, and when they leach into the soils, they destroy the basic structure of the soil and they can make it toxic. So this is one of the things, but I'm sure you'll find lots of information on the web if you look for this particular topic.
Sure, sir. Thank you, sir. Yeah.
मिश्रा जी, आपकी उंगली आ रही है कैमरे के सामने, उंगली अंगूठा.
Sorry.
That's all. I have
as
just
long as the thing.
One question from my side, that normally the waste what we'll get, textile waste, it will be a mix of blends also. It may not be solely cotton or solely polyester. Will it be right way to use as it is, or we'll have to make a sorting kind of thing?
There is no requirement, sir. One can use as such also.
As such also.
Yes,
so there's no impact on the strength of the tiles or
strength,
like this?
Sir, strength, it will not affect adversely. Of course, if it is a long fiber you are using, of course you will get better strength. And if it is a short fiber, you will get the lower strength, sir. That is there, but it will not affect badly on that.
Okay, thank you.
See, another point which has come out very clearly here, and Dr. Parmar has also endorsed that. Mr. Kapoor had raised a point about the commercialization of the particular project. What is very important for any particular project, any study, is that it should be commercially viable for it to be put in practice, for it to survive. And until unless we work out the ideas and convert them into businesses, into viable businesses, I don't think it will be a very fruitful kind of an exercise. So I think all of us have to put our heads together to find out how and which way it can be done. Dr. Parmar is taking the lead on that. And I'm sure people like Mr. Kapoor will be able to contribute a lot in that particular area.
Sure, Doctor. Sure.
Any further questions?
Thank you.
Hello.
Welcome.
Hello.
Any further questions in that area, please?
Hello.
Mr. Wazirani put in a lot of questions. Why don't you start asking your questions, Mr. Wazirani? Chat box, you have put in a number of queries. If you're there, can we raise the question?
हाँ बस 2 मिनट, ये मेरा जूम मीटिंग चल रहा है, 2 मिनट। Hello.
I will read out one of the questions from Mr. Wazirani. The first question Mr. Rakesh Wazirani has raised. When receiving textile scrap for recycling, do you happen to know how recycler identifies, verifies composition of incoming waste? Dr. Parmar, can you answer that, please?
I think the question is related to segregation of waste or something else.
Yes.
I could not understand properly. So that's why I think Vikas ji has already asked that question, that if it will impact on.
Yeah.
So there is no need to segregate that one. Of course, we have to cut into short pieces, sir. That length can be reduced according to the requirement, and it can be mixed to the matrix, and then accordingly one can use it in different products.
There's another question from Mr. Wazirani. Is the presence of informal waste collection aggregator sector for textile manufacturing scrap is it a boon or a bane? For example, on one hand, getting greater waste, but perhaps losing textile quality data that could come directly from the manufacturer.
So let me read that one.
Yeah.
Sorry, can you explain it, sir? That question.
Mr. Wazirani, is he still there?
What you want?
I think what he's referring to here is the amalgamation of different kinds of waste, whether that reduces the quality of the waste. If it comes directly from the manufacturer, the quality of waste could be better. So that is definitely true. But then all the waste cannot be segregated by the manufacturers themselves. If I've understood correctly, this was his question. So some of the manufacturers, and I think businesses have been developed in that particular area where specific waste have been collected and sold as particular waste, and it can be used for different applications. The segregation of dyed scraps, for instance, the pre-user waste has been already started in a big way by people who are manufacturing recycled yarns. There are several companies in India who are doing it, and I'm sure that that has its advantages. But then when we come to the common public, when everybody is throwing waste out, I think it is very difficult, and it has been integrated into different products. It is very difficult to segregate that. So the question here that comes in is whether collecting the waste is a boon or a bane. So in that aspect, I am sure that it is a boon. And others can share their opinions, please. This is an open forum. I would invite all of you to kindly share your views. Please come forward. Thank you so much.
Hello.
Hello, yes, Mr. Chandak.
सर मैं सूरत से बोल रहा हूँ, डीसी चांडक.
Yeah, Mr. Chandak, please tell me.
सर हम लोग यहाँ पे है ना पर मंथ का 4000 कोल यूज करते हैं, 4000 टन कोल, इंपोर्टेड कोल.
Okay.
तो सर क्या हम ऐसा कुछ जैसे आपने बताया कि कोई भी मतलब टेक्नोलॉजी यूज करके मतलब फ्यूल बना सकते हैं, यहाँ पे यूज कर सकते हैं, ऐसा कुछ आप गाइड कर सकते हैं सर हमको?
क्या सर आप क्या करते हैं सर कोल का?
सर हम लोग हमारा प्रोसेस हाउस है हमारी. हेलो. हाँ तो उसमें सर हमको कोल यूज करते हैं हम एज ए फ्यूल 4000 टन पर मंथ.
हाँ ठीक है.
तो सर उसके जगह पे हम क्या यूज कर सकते हैं जैसे आपने बताया ना? कि भाई आप क्रॉप है कोई भी रीयूज कर सकते हैं, ऐसा कोई हम फैक्ट्री यहाँ डाल सकते हैं जिसमें हम रीयूज करें और उसको एज ए फ्यूल यूज करें वापस। तो ये बहुत बड़ा सा इन्वेंशन हो जाएगा हमारे लिए।
सर उसमें हमने एक स्टडी आपको शो किया था, दिखाई थी
जी।
उसमें हमने ये दिखाया था आपको कि कैसे टेक्सटाइल्स को एज ए फ्यूल उन्होंने कन्वर्ट किया है सॉलिड फ्यूल में।
जी 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 जी।
तो वो जो वेस्ट निकल रहा है उनको उन्होंने प्रेस करके उन्होंने इसमें मिक्सिंग करके एक सॉलिड वेस्ट बनाया, सॉलिड फ्यूल बनाया।
राइट
दैट
सर।
क्या फ्यूल, वो फ्यूल जो है आप वो बॉयलर में या किसी में भी यूज कर सकते हैं। एक स्टडी मैंने आपको शो की थी, बाहर की स्टडी है।
हाँ जेपान लिखा, राइट सर, जेपान लिखा था ना आपने, वही
हाँ
वाली
जी
है सर।
हाँ जी हाँ।
हाँ
तो
तो सर
वो किया जा
जी।
सकता है।
सर सूरत में 400 प्रोसेस हाउस है
जी।
और हम 3 प्रोसेस हाउस मिलकर इतना यूज कर रहे हैं यहाँ पे, बहुत बड़ा मतलब अगर सर कोई आप हेल्प करो हमको तो सूरत में सर एक बहुत बड़ा चमत्कार हो सकता है। हम एक फैक्ट्री डाल के ये रीयूज करके वापस सबको दे सकते हैं कि भी आप यूज करो, देश के लिए भी अच्छा है, नेशन के लिए, सबके लिए बढ़िया चीज है सर। तो आप प्लीज मुझे इसका मैंने मोबाइल नंबर ईमेल आईडी भेजा हुआ है सर, तो प्लीज आपका ईमेल आईडी और मोबाइल नंबर मिल जाएगा सर, तो आपसे कांटेक्ट कर लेंगे फ्यूचर में।
ठीक है, आपने अपना भेज दिया है ना, टेक्सटाइल एसोसिएशन को भेज दिया है
जी
अपना
भेज दिया
नंबर सब?
सर।
ठीक है, वो तो कोई बात नहीं, वो टेक्सटाइल एसोसिएशन से हमें हो जाएगा, उनका ऑर्गेनाइजर है वो।
ओके सर, थैंक यू सो मच
सर। मिस्टर चांडक, आप एक ईमेल भेज दीजिए
जी
आपकी अपनी कंसर्न्स और क्वेरीज को रेज करके,
जी
और
सर।
हम लोग उनको डॉक्टर परमार को फॉरवर्ड कर देंगे, देन द टू ऑफ यू कैन बी इन टच डायरेक्टली।
ओके सर, थैंक यू सो मच सर। ठीक,
वेलकम।
Hello. Hello.
Yeah, somebody from Mitapalli Spinners.
Yeah, this is Shashidhar from Metapalli Spinners, Andhra Pradesh, Guntur.
Right.
100% cotton spinning units. We are producing about 1% of input as microdust. That microdust,
Okay.
where we place?
Sorry, come again.
Microdust produced in cotton spinning unit.
Yeah.
Where we can utilize that one. 1% of the input is almost produced as microdust.
I understand. Dr. Parmar, I think this is your field.
Yes, sir. Yes, sir. That my presentation on developing various products on out of these types of waste material, and I have mostly discussed about these tiles and other things, so that microdust can also be mixed with these matrix and tiles can be made out. There is no problem, sir. If you can send us a kg of that or a half kg of that material, we can make some tiles out of that. There is no problem.
If I can just put in my 2 cents in case of microdust, due to being of very small size or very small length, if it can't be used as a fiber, I think it can be used as a fuel briquette if we mix it something like gobar, etc. So, there has been studies where this kind of agriculture waste has been used with gobar, and fuel briquettes have been made which can be burned without any, I should say, environmental hazard. That's my view. Thank you.
Thank you for this advice, sir. Thank you.
Sir, why not that microdust goes as a filler? Because वो बारीक है, महीन है, उसको प्रोसेस क्यों करना है? उसे डायरेक्टली फिलर की तरह क्यों नहीं यूज कर सकते?
उसका जो है वो जलाता है तो उतना आग तेजी से जलती नहीं है, वो मिट्टी है एक तरफ से।
कैलोरीफिक वैल्यू उसकी बहुत कम होती है, जो डस्ट है उसकी कैलोरिक वैल्यू इट इज वेरी स्मॉल, very less, so it is not being used for making that type of things. You have to finally mix it with the other product to make some that, like Mr. Kaushik has mentioned about that, making this that type of product. And secondly, what we have discussed during my presentation, that you can use it making tiles and other such type of product.
I think the best thing
So-
would be to send it to Dr. Parmar and then they can make some kind of pilot study.
Yeah, better. We will send, sir. We will send. We will send the same.
Okay, sir.
Thank you, sir.
Okay, sir. Thank you.
Thank you, Mr. Shashidhar. Shailesh, I must compliment you for those 2 cents of yours, which never seem to get exhausted. You always have those 2 cents.
No, sir, if I give 100 cents out of 85, only one, it will be 0. So I give it in bits
Okay.
and pieces.
Anyway, any further questions, please?
सर आपका अंगूठा उंगली बार बार आ जाता है कैमरे के सामने.
Sorry. You have to learn to keep it in the right place.
Yeah.
Any further questions, please?
सर मिश्रा जी, अगर किसी को सवाल नहीं है तो मेरे पास तो बहुत सारे सवाल हैं. ममता हियर.
वो मैं आपकी लिस्ट में देख रहा था.
हाँ.
कोई दिक्कत नहीं है.
हाँ.
We can take those questions as long as we are here. I think we still have little time.
Yeah.
And we had allocated until 1 o'clock. So we
Right.
still have 9 minutes.
Yeah.
Or if there are more questions, we can still take them further. It all depends on how Dr. Parmar is organized.
Okay. Dr. Parmar, may I?
Dr. Saab, आपका कोई और?
Okay.
Doctor, yeah.
Yes.
Please.
Yeah. Being a newbie in this alien field for me, right? I've been reading some research papers, circular economy, sustainable economy, waste to value, best conversion methods, which are my way was to convert this waste into low carbon products. मतलब ऐसे products जिससे environment final बनने के वक्त के पहले processing also should be low carbon, right? So what I, as a newbie and alien, I understood हाथ से there are a lot of people who are out of jobs. So why not use human technology and convert them with, sewing, handcrafting, weaving, all those stuff. And here I see Dr. Parmar is using so much of technology to convert that into from one sector to another sector, like tiles and automobiles and all that. So as per, I'm a very nascent person in this field, sir. Please pardon me if I sound otherwise. So what Ellen MacArthur and all those folks who are who understand circular economy, they say that एक सेक्टर से दूसरे सेक्टर में कन्वर्जन नहीं होना चाहिए. जैसे टेक्सटाइल का टेक्सटाइल में ही रहे, इट्स कॉल्ड क्रेडल टू क्रेडल. आई एम श्योर डॉक्टर परमार नोज ऑल दिस थिंग्स. सो अभी हम टेक्सटाइल से कंस्ट्रक्शन एंड ऑटोमोबाइल में अगर प्रोडक्ट्स बनाते हैं तो वापस उनका डिसमेंटलिंग एंड रिसाइकलिंग फॉर द सेकेंड लाइफ विल बी अ बिग इश्यू. तो ये एक चीज है, मुझे समझ नहीं आ रही है. आर वी डूइंग इट राइट?
ओके, मैं आपकी नॉलेज के लिए बता देता हूँ कि टेक्सटाइल में अब जो नया ट्रेंड चला है, नया ट्रेंड तो मैं अब कह रहा हूँ आपके लिए, अदरवाइज इट इज नाउ वेरी ओल्ड, दैट इज ए टेक्निकल टेक्सटाइल्स. टेक्निकल टेक्सटाइल्स में डिफरेंट ब्रांचेस हैं, डिफरेंट एरियाज हैं, सेगमेंटेशन अलग अलग बनाए गए हैं. Some are protective textiles, some are composite textiles, some are automotive textiles, some are other. Okay, geo textiles are also there. Okay, industrial Inditech also there. Industrial textiles are.
Okay, sir.
So textile ने सारे फील्ड कवर कर लिए हैं. जो उन्होंने बोला था कि एक फील्ड से दूसरे फील्ड में नहीं जाना चाहिए, that has been now broken by textile industries.
Okay.
Now textile industry में से जो प्रोडक्ट बन रहे हैं वो ऑटोमोटिव टेक्सटाइल्स में भी बन रहे हैं. वो कंपोजिट में जब पहुंच जाता है तो कंपोजिट का यूज हर जगह हो जाता है. जैसे मैंने टाइल्स बनाया, इट कम्स अंडर कंपोजिट. ओके, so it is a composite textiles. So we have used some material, we have used textile material and made out of that there is some composite material. So it is a composite now. So you can make any product out of that. There is no problem. This is our view as a textile person.
Thank you, sir. Thank you.
May I add a little further? When you said about textiles waste being recycled into textiles, one of the things when you talk about textiles, you're talking basically about yarns and fabrics, if I'm not mistaken. Am I right?
Fabrics only, sir. Fabric pieces. I'm still at the tailor's cutting waste.
Okay.
Yeah.
Okay. So the fabric has to be made from yarns, and yarns have to be spun from the fiber. So the critical spinning length for a fiber is for a yarn is 12 mm of fiber length. Below that, it cannot be spun into a yarn. Number one. Number two, it can be used for non-wovens, and there are certain applications where it is being used for non-wovens. So that particular premise that it should be, when you talk about cradle to cradle, yes, it did have a relevance at one point of time. But like Dr. Parmar has very clearly pointed out, there is so much of interlocation and extrapolation of products and properties that we are not. These are the areas where I think interlinking technology really has to come in.
Okay, sir. Yeah, thank you. Thanks for that elaboration. Thank you.
You will.
Sir, I have a query to Dr. Parmar sir. Sir, are we doing any recent project on medical textiles for the improvement in medical industry in India?
I think you are having some communication problem. We could not able to hear your sound. Mishra sir, I'm right. We are not able to.
Yeah, you're right. Yeah, Mr. Nandi, can you repeat that question, please?
Sir, my question is, suppose all European countries are focusing more on medical textiles. So in India also, are we focusing on medical textiles, or our present focus towards something else?
No, we are working on medical textiles also. In India, our government has given a various types of center of excellence to different organizations. Like in NITRA, we are having a center of excellence, protective textile and automotive textile. CITRA is having a center of excellence in the medical textile. They are working on medical textile, but there is no boundary. One can do any work anywhere, no problem. Like we have worked on sanitary pads, various types of reusable sanitary pads. We have developed some technology. We have transferred that technology to industries. So there is no any boundary, but main focus, like CITRA is working on medical textile. They are focusing much on medical textile. We are having protective textile. We are working mostly on protective textile and also working on other areas. So that is going on.
मिश्रा जी इस बार मेरे 2 सेंट नहीं है 0.25 सेंट है replying to Mr. Nandi's question that medical textile in the form of non-wovens is nowadays finding a big usage in medical textiles in mass PPE. Of course, there is a whole plethora of other areas also. Thank you. So I can find 0.25. So only.
Thank you. Any further questions, please? Mr. Nandi, actually, to elaborate further, this particular series has been started with a view of focusing on sustainability. And this is the first of a series of lectures that we are planning on sustainability, on the various aspects and the methods, means, the challenges, and the solutions, the innovative solutions. So this is the idea. Technical textiles is another field which we will be taking up separately, and we will be definitely addressing your questions in that particular webinar as well. So at this point in time, we are starting with this series on sustainability, which has been brought out very well by Dr. Parmar. And it is, at this point of time, probably the most burning issue, and not technical textiles, where sustainability, to quote a very popular and unpopular leader, Mahatma Gandhi, he said, there's enough for our need, but not enough for our greed. So with that particular byline, I think it is very important for us to understand that until unless we regenerate all that we are using, we will be depleting our sources, like I said, and we'll be starving ourselves for a lot of things that really matter. So sustainability we took up as the first topic for a discussion, because we felt that sustainability was the particular topic, particular area which needed a lot of focus. I was surprised that last May there was a huge section for sustainable textiles, and there were machines which are being promoted for sustainable textiles. So the world has realized, the world has woken up to the fact that sustainability is a very, very critical issue. So we'll definitely be taking up your points on technical textiles later when we come to that particular chapter. And with that, I get back to Dr. Parmar, if there's anything that you'd like to add.
It's okay, sir. Now, I think if somebody have any question, then what they do, they can send a mail to Textile Association, and we can reply it accordingly. When I get from them, then I will reply to directly, or to Textile Association, I can reply. There no problem. You can send any question to us.
Thank you, Mr.
Thank you very much, Dr. Parmar. Yeah, sorry.
Thanks to both of you, sir, for the details, sir. Thank you, sir.
You're welcome. You're welcome.
Thank you, Dr. Parmar. Thank you, Mishra ji.
Thank you, everyone.
You're welcome.
Thank you,
Thanks,
everyone.
tons, Nitra and Dr. Parmar and Mishra ji, for taking my questions also. An entire newbie. Thank you. I'm looking forward to the series, sir.
Yeah, yeah, you're welcome. You're welcome.
Thank you.
We'll be getting in touch. We'll be putting that on our calendar very soon, and we'll be touching a lot of topics. May I request Mr. Vikas Shastra for a vote of thanks? Vikas, please.
Firstly, I will thank Dr. Parmar for giving so detailed information about something new which can be done to handle the textile waste. Thank you, Dr. Parmar, and thank you very much, everyone, for attending this, giving the right direction to the webinar. And again, I thank to Kamal Mishra ji taking this initiative, taking this webinar forward, and I'm quite sure that the calendar will be released very soon, and we'll have a series of webinar in coming times too. Thank you very much, everyone. Thanks a lot.
Thank you very much, sir,
Thank you
for inviting me over here.
Thank you.
Thank you so much.
Thank you, everybody.
ज़्यादा ही
Bye.
थोड़ा सा कैसा है